Dear children, now let's continue the chapter decimals from book 2. We are dealing with convert each of the following fractions into decimals. So we are going to see how to convert the fractions into decimal. If the improper fraction or mixed fractions are given, first we have to make the improper fractions proper, or we have to reduce it to the lowest term. And if it is in the form of mixed fraction, then we have to convert it into the improper fraction. If possible, we have to reduce it to the lowest term, and then we have to divide in a usual manner. So let's solve. Here we are having first example C. 7 upon 2. So the meaning of this is 7 divided by 2. So further we can divide it this way. 7 divided by 2. 2 3s are 6. Remain 1. Now we have to divide this number until we get the remainder 0. So we shall take the next digit down. So 7 can be written as a 7.0. So put the decimal point here. Take the next digit down, that is 0. Now 2 5s are 10. 2 5s are 10, and from 10, 10 goes out, remains 0. Therefore, 7 by 2 can be written as 3.5. So after solving this fraction, we'll get 7 by 2 equals to 3.5. Similarly, let's see E example. So E example is 7 is to 2 by 5. Let's convert into the improper fraction. 7 5s are 35 plus 2 37 divided by 5. Further, the next step is we have to divide. So the meaning of 37 divided by 5 is 37 divided by 5. Further, let's divide. 37 is dividend, 5 is divisor. Therefore, 5 sevens are 35. Subtract it. So remains 2. Now we have to divide this number until we get the remainder 0. And 37 can further be written as a 37.000. Okay, so increasing 0 by putting the decimal point won't alter its value. So we can write 37 as a 37.0. Now let's take the next digit down. I have taken it down. And now as I have taken the digit after a decimal point, so first we have to put the decimal point. Now 5 4s are 20, and from 20, 20 goes out, remains 0. Therefore 7 is to 2 by 5 can be written as 7.4. So this is how we solve the problems. Now we are having G example. 27 divided by 48. So 27 and 48 are divisible by 3. Okay, 8 plus 4 is 12, 7 plus 2 is 9. So let's divide them and reduce them to the lowest term. So after dividing numerator and denominator by 3, we'll get fraction 9 upon 16. So let's rewrite this. 27 upon 48, that equals to 9 upon 16. These are equivalent fraction, and the meaning of 9 upon 16 is divide 9 by 16. Now let's divide them actually. So 9 is a dividend and 16 is a divisor. 9 can be written as a 9.0000. So we have to divide this number until we get the remainder 0. Now let's start dividing. So 9 is not there in table of 16. You know that we can't divide smaller number by bigger number. Therefore 16 zeros are 0. From 9, 0 goes out, remains 9. Next, take next digit down, and when you're taking next digit down and there is a decimal point, so we have to put the decimal point here. Next, 19 5s are 80. Therefore, the nearby number to this is 16 5s are 80. So from 90, 80 goes out, remains 10. Take next digit down, has become 100. Now 16 6 are 96. From 100, when 96 goes out, remains 4. Take next digit down, that is 0, and has become 40. And now 16 2s are 32. From 40, 32 goes out, remains 8. Take next digit down, has become 18. And you know that 16 5s are 80. From 80, 80 goes out, remains 0. So what quotient we have obtained here? 0.5625. Therefore, 27 upon 48 can be written in decimals as 0.5625. Hope you have understood this. Now let's see the next part. It's a word problem, exercise 3.10. So last part of this chapter we are dealing with. Let's see the word problems. B problem. 2.25 meter of canvas is required to make a tent. How much canvas is required to make 12 such tents? So, the cloth required to make one canvas net or tent is 2.25, and we have to make 12 such tents. So, to do that, we have to multiply this decimal by 12. So, now we have understood the keys. Now, let's write the statements. First statement, canvas used to make a tent equals to 2.25 meter. Next, number of tents equals to 12. Cloth required to make 12 such tents equals to question mark. So our key is multiplication. Let's multiply 2.25 meter by 12. 12 5 is 16, 0 here 6 carry, 12 2s are 24, 24 plus 6 is 30, 0 here 3 carry, put the decimal point, 12 2s are 24, 24 plus 3 is 27, therefore 27 meter. So the final statement will be 27 meter of canvas is required to make 12 such tents. Hope you have understood this now. Let's see D problem. Length of one textbook is 15.6 centimeter. What will be the length of 8 such textbooks placed in a line together? Yes, so here they have given the length of one textbook and we have to find the length of 8 such textbooks. So to find the length of 8 such textbooks, we have to multiply, isn't it? So let's write the statements first. Length of a textbook equals to 15.6 centimeter. Number of a textbook equals to 8. Length of 8 such textbooks equals to question mark. Key multiplication. Now let's multiply 15.6 centimeter by 8. So let's do that. 15.6 centimeter multiply by 8. 8 6 are 48, 8 here 4 carry, 8 5 are 40 plus 4 44, 4 here 4 carry, 8 1s are 8 plus 4 is 12, and here is only one decimal point, therefore we have to put the decimal point after one digit from right side. Therefore 124.8 centimeter will be the length of 8 such textbooks, and that will be our final statement. Now let's go ahead with the next word problems. Yeah, so we have a F word problem here. Vaibhav walks 84.7 km in a week during his morning walk. How much distance does he walk each day if he walks an equal distance each day? Yes, so here the record of a week is given that he walks for a distance 84.7 kilometer, and in a week there are 7 days. So when we divide this distance by 7, that will give us the distance covered by him each day. Okay, so they have asked each day how much distance does he cover, isn't it? So to do that, we have to divide this distance by 7. Okay, finding the cost of finding the cost of per item. So this can be done by dividing. Okay, and what is division? Division is nothing but distributing the things into equal groups, isn't it? So let's write the statements. Distance covered by Vaibhav in a week equals to 84.7 kilometer. Number of days in a week equals to 7, and distance covered by him each day equals to question mark. Key division. Now let's divide 84.7 by 7. 7 ones are 7. From it, 7 goes out, remains 1. Take 4 downside. 7 twos are 14. From 14, 14 goes out, remains 0. Put the decimal point. Take the next digit down, let it 7. 7 ones are 7. From 7, 7 goes out, remains 0. Therefore, each day he covered a distance of 12.1 kilometer. And hence the proof. Now let's see the next problem. Rohit traveled 11.5 kilometer in 4 days. How many kilometer did he walk in 1 day if he travel an equal distance each day? So dividing a thing into equal groups is nothing but division. So it is one more problem of division. So let's write the given things first. Distance covered by him in 4 days equals to 11.5 kilometer. Number of days equals to 4, or first you can write the statement number of days equals to 4, or distance covered by him in 4 days equals to 11.5 kilometer, and distance covered by him or distance traveled by him each day or 1 day equals to question mark key division. So now let's divide 11.5 kilometer by 4. Therefore 11.5 divided by 4. 4 twos are 8. Remains 3. Put the decimal point here and take the next digit down. 4 eights are 32. From 35, 32 goes out, remains 3. Take the next digit down, that is 0. 4 sevens are 28. From 30, 28 goes out, remains 2. Take one more digit or 0 down. You know that increasing 0 at the right side of the decimal won't alter its value. Therefore, first we had taken 0 downside. Now we are taking next 0 downside. So, 4 5s are 20. And now we have divided the 11.5 completely without leaving any remainder. Therefore, we can write that Rohit traveled 2.875 kilometer per day. And hence the proof. So with this, we have finished the chapter decimals, and now we are going to start the new chapter Symmetry, Pattern and Nets from book 3. So let's understand what is symmetry, pattern and nets stepwise. So what is symmetry? If a figure is folded into two halves in such a way that both the halves are equal in shape and size, then we say that the figure is symmetrical and the phenomena is called symmetry. When a figure is folded or cut into two equal halves, so each part looks identical. Each part of the figure or the thing or an object looks same. So such a figure or things are called symmetrical things, or the phenomena is called symmetry. Let's understand the symmetry with few examples. You can see this stapler box. So you just don't see the color or the picture of this box. Consider this is a cuboid, okay? And when I divide this exactly, each part of this box will look same and each part is symmetrical to one another, isn't it? So that concept is called symmetry. Now if we see this sharpener, if I cut this sharpener into two halves, it will not look same, because here it's having curves and here it's having few edges. So both parts will not look same. Even if we cut horizontally, it will not look same, because at one side it has a screw and blade, and the next part will not be having a screw and blade. That will not look similar. But if you see this cap, so this cap is of whitener. If I cut this, or if we divide this shape or cap into two hulls from this side, it will divides or cuts this cap exactly into two equal hulls, and each hull will be identical to one another. But if I cut this from this side, okay, from vertical, if I cut vertical, it will not look same or symmetrical. If I cut it horizontally, okay, from this side, here it is having a handle. From here, when I cut it, then each part or each hull will look exactly similar. So such a phenomena is called symmetry. Okay, so even you can identify how we can draw the lines of symmetry. Okay, so what is line of symmetry? The line which divides the figure into two equal halves. Okay, that line is called the line of symmetry. Now here we are having examples. Okay, so just see the letter A. We have to cut this letter A in such a way that it should look identical. Okay, so when I cut this figure vertically, each part of this letter will look similar. Just see. Now you can just see. Here I have drawn a vertical line, and this line is called vertical line of symmetry. If I draw horizontal line of symmetry, each part of this letter will not look same. Just see here. I will put the scale. If I put the scale, you can just see the part covered by a scale and the leftover part, if you compare, both are not symmetrical. So we can't say that the horizontal line of symmetry is possible for this figure. No. For this figure, only vertical line of symmetry is possible. Now, let's see the next figure, that is letter I. Here, when I draw a vertical line of symmetry, both the part of this letter or figure looks alike. Therefore, yes, it is possible to draw vertical line of symmetry. Even we can draw horizontal line of symmetry. You can see, you can just see the part covered by scale or a ruler and the leftover part, both looks alike. Therefore, here horizontal line of symmetry is also possible. Right? Therefore, we can say that vertical and horizontal lines of symmetries are possible, and here we can write only horizontal line of symmetry, isn't it? Now, let's see what are asymmetrical figure. The figure which do not look same. Such figures are called asymmetrical figure. If one half of each figure is not equal to the other half, such shapes or figures are called asymmetrical figure. Now, if I cut this figure into horizontal line by horizontal line, this figure will not look same. Each part or each half of that figure will not look same. So that is asymmetrical figure. And this is symmetrical figure where the lines of symmetry is possible. When the lines of symmetry may be horizontal or vertical. If none of these lines are possible for a figure, then such figures are called asymmetrical figure. So now let's see.